Hey everyone, I'm just jumping in here to say that this is part 2 of 2. In part 1, we talked about the foundational variables and equations that we needed, so go back and check that video out. If you haven't already seen it, if you have seen it, go around and let's get started. And then if you solve for IUL, which isn't hard, it's just a little bit of algebra, you get Q times the quantity of 1 minus D over P minus S max. Alright, enough about times for now. Let's start calculating some costs. We're going to start with a nice easy cost, and that's the production cost for a widget. You may recall that one widget cost C dollars, and that in a week, D widgets are demanded. CD is the first component of the total cost equation. Next up is the order fee per week. If you remember, there was one order fee for the whole thing. To order the production of Q widgets, during this time you needed to pay R dollars. And we're just going to divide that by the number of weeks in one cycle. I keep saying weeks, but it could be any unit of time. Remember that. So our order fee is R dollars, and we calculated that the time to return to the upper limit is Q over D. So how much of this fee do we have to pay per week per unit of time? R dollars divided by TUL, which is the same as RD over Q. Just like that, we have our ordering cost. Next is our fixed shortage cost. And the units on FS were actually dollars per widget. So what is the maximum number of widgets that we plan on being short? It's S max. So if we want to get the total fixed shortage cost, we would do FS times S max. And then if we're doing the fixed shortage cost per unit time, or per week in this case, then we need to divide this cost over all the weeks, which, like I just said, is Q over D. So we have this, and then we can simplify. And just like that, fixed shortage cost. Variable shortage cost does not just depend on the maximum number of widgets we plan on being short. It also depends on the time that those widgets spent in backlog. So we have VS, which is our dollars component, times the number of widgets short we are, times the amount of time that each widget spends being short. So here's where the shortage is. And we're doing time times the number of widgets short we are. So this sliver of time times this amount short, plus this sliver of time times this amount short, and so on. And what you end up getting is the area between the curve and our time axis here. And you can look at this area and kind of see two triangles happening here. So I'm going to redraw that on the other slide. So we have the area above the curve, which was these two triangles. The base of this triangle is the difference between these two times, and the base of this triangle is the difference between those two times. And the height of both of those triangles is S max. The area under this curve takes care of both of these components here. If you remember the formula for the area of a triangle, it's 1/2 times base times height. So we have 1/2 times S max multiplied by the difference between these two times, which we already calculated at the beginning, which was S max over D. Then we're going to add the area of the other triangle, multiply by the height. And then the base is the difference between these two times, which we calculated at the beginning as S max over P minus D. And if you like algebra, you can go through and do the simplification yourself. But this is what you end up with in the end. And remember that we want the variable shortage cost per unit time, and in this case week. So we got to divide all that by TUL. TUL equals Q over D. So finally we end up with our variable shortage cost per week, which is this expression right here. Last component of the cost equation is the warehouse cost. I think I called it a tax before. That was a long time ago now though, so I don't remember. But that was the percentage I. It's a percentage that we add on to the cost of producing each widget because we got to worry about storage expenses. So maybe it's 7% the price to produce the item or something like that. So you would do 0.07 times whatever the cost of the widget is. But if we want total warehouse cost, it depends on how many widgets we're storing and how much time we spend storing each of those widgets. And this looks awfully familiar. In particular, it looks familiar to the shortage stuff we were just doing. Except now, instead of doing the area between this part of the curve and the axis, we need the area under the parts of the curve where we're actually using the warehouse. And we're going to cut it off right here because that's when a new cycle begins. And we're just concerned with one cycle right now. So again, we have two different triangles, which I'll redraw on the other slide. I know you remember that this time here was IUL over D. And you also remember that this time here was IUL over P minus D. Add the area of the other triangle, and then a ton of really fun algebra, to get this expression here. And we already calculated IUL. Remember from way long ago, this was IUL. We had two different ways to express this time. We thought we'd solve for one of the variables, and now we can plug this into that cost. This is our warehouse cost for one cycle. And again, we're going to divide by TUL to get warehouse costs per week, or unit time, you know what I mean. Oh, and I hope you didn't forget that TUL, it equals Q over D. Anyway, this is our final expression for the warehouse cost or the storage cost per week. And tying it all together now, we have our total weekly cost. We have the cost that comes from the price to produce our widget, plus our weekly ordering cost, plus our fixed shortage cost, plus our variable shortage cost, plus our warehouse cost or our storage cost. And we express this as a function of Q and S max. We kind of just assume that everything else is given to us based on the kind of system that we have. But more realistically, what we can control is how much shortage we allow and how many widgets we order in each order. So it's really good that we have a cost equation that incorporates those variables. And there's going to have to be a separate video on minimizing that total cost. What order quantity should we go with and what maximum shortage should we go with to minimize cost in our inventory management. And there are other simplifications you can make to get even more equations. It's so much fun. It all starts right here. If you like this video, go ahead and hit the like button. If you want to see more videos like it, you should let me know by hitting the subscribe button. And you should put your questions in the comments.